Okay. Anna, how is this going to work? Are you going to say a few words as well, or should I just start?
You can start if you want. I'm ready.
Okay, okay. Okay, in that case, I will start. Well, thanks to everyone who showed up. I'm glad a few people came, even though the other session is certainly quite interesting right now, but it's recorded, so you can have a look later on as well. So I'm going to talk a bit about our company, Active Fiber Systems. We are situated in Jena in Germany and are actually a spin-off from the Fraunhofer EUF that organizes the Photonics Days. And I think, I don't know your background, so maybe some of you know already what I'm going to tell about a few of the applications. Maybe for some of you this is new. However, high work rate ultra-fast lasers have lots of applications. So you can do many pump probe experiments. You can generate XUV radiation, do biomedical imaging, XUV imaging, and photo emission spectroscopy, just to name a few buzzwords. But this would go far into too much detail to elaborate on this. So let me say, all of these applications have in common that you need a certain peak power level and a certain energy to enable the application. And then you have to increase the repetition rate and thus the average power to get a good speed for your application or improve the signal to noise ratio. So you don't want to wait for many days to get your image. You want to do it within seconds, so you need high repetition rates. And to do so, you have to improve the laser sources. So for many years, there were titanium sapphire systems and other bulk systems that could deliver high peak powers, but they suffer when it comes to high repetition rates. So typically, these laser sources, they all use the so-called chirp pulse amplification scheme, which was awarded a Nobel Prize a few years ago. In our case, we're using this chirp pulse amplification scheme, where you basically stretch your laser pulse to have a reduced intensity in the amplifier, and then you compress the pulse afterwards to get a peak power that wouldn't be possible directly in the amplifier. And what we are using is fiber laser technology as main amplifiers and preamplifiers. So basically, the advantages of a fiber, I think most of you know this. So it is basically a total internal reflection that guides the light. So you have some active core in this case, where the amplification happens, and the light is directly guided in the fiber. So you have a good beam quality. The system is very heat resistant because you can dissipate the heat over the surface of the fiber, which is quite big compared to the volume. And they are easy to pump as well. So of course you have to put energy into the fiber to extract energy later on. So this is basically the core technology behind our laser systems. And of course, these fiber lasers, they also have some drawbacks. So they see limitations when it comes to pulse energy and peak power. You can damage your fiber facet, or you get nonlinear effects, for example, self-phase modulation. And this basically distorts the pulse shape, so you don't have a nice and clean pulse anymore. But that's important for the application. Furthermore, you could have thermal issues. So here you can see a fiber that gets destroyed basically because there's too much heat and it can't get removed. But this can be overcome by a proper cooling and a proper mounting. There are more limitations, like how we say real thermal issues, when you have the effect that's called mode instabilities. It's a bit more complex, but basically it limits you in terms of average power. And what you can do to reduce these nonlinear effects, you can scale the mode area. I will show a slide on this. And you can also use parallel amplifiers instead of just one single amplifier. And the mode area scaling. Well, typically this is a microscope image of a typical telecom fiber. So you can see this entire fiber is around 100 micrometer thick, and the core is only a few micrometer. And now you can imagine if you want to put lots of energy in this small core, you run into limitations at some point. So you can use larger fibers that have a larger core already. And what we developed is a really large fiber. This happened like 10 years ago at the university back then. So we are using a fiber that has a core of the size of this entire fiber. Basically, you have a much bigger area that you can fill with your laser pulse, so you can increase the damage threshold significantly. And the reason this works, maybe just a glimpse into the detail behind that, we are subject to research for many years. So basically, some of you may have heard that if you increase the core, you get multimode fibers. And so how can you do that? What you do, you have the doped area, because we use the fibers to amplify the beam, right? So the doped area is only in the core, and you can design it in a way that the overlap of the fundamental mode with the doped area is much larger compared to the higher order modes. And this way, you achieve basically fundamental mode operation, because only the fundamental mode gets amplified. The higher order modes don't see that much amplification. But this is far too detailed just to give you an idea of what's behind this technology. And the other technology that was developed also by us back then is to use many main amplifiers instead of one single amplifier. You can imagine before the main amplification step, you split your beam into several replicas, and these replicas get amplified. And afterwards, you recombine them, and you get a pulse that would be too intense for a single amplifier to handle it. So this is called coherent combining. And yeah, this way, the achievable laser parameters are not really limited by physics anymore, only by how much room you have and how much money you have. Yeah, these systems, they could overcome the limitations of a single amplifier, as you can see here. So this shows the average power over the years for ultra-fast ytterbium fiber laser systems. And you can see the classical single emitter systems, they kind of saturated a decade ago. So there was not really a lot of development anymore. And the combining systems, they were able to further scale the output power using this combining technique. And there are also some publications on that. And this is basically the parameter regime where our company operates. So we are really specialized on high power fiber laser systems and all the add-ons that you can imagine. Our company, yeah, as I said, is the unique thing about us. We are focused on have a quick transition from the research results into reliable commercial systems. So we want to have the researchers use the best systems available and make them available quickly. So our main market is obviously research, and we are the technological leader for high power fiber lasers, ultra fast fiber lasers. We just moved to a new building like 2 years ago and have lots of room, lab space and office space, and also have been growing quite drastically over the last couple of years. So we have 40 people now, and you can see 7 years ago it was only one person putting together all the systems. Yes, we have a big portfolio of different platforms that we typically customize to the needs of the customer. And yeah, I don't want to go into detail of all this. You can also have a look on our website. Basically, it's ytterbium-based laser systems, thulium-based laser systems, some smaller special systems, and add-ons to all these. So basically, fuse cycle generation, XUV generation, and other frequency conversion techniques. Okay, so the key message of this, we develop, produce, and sell femtosecond lasers with the highest average power in the world, customizable and versatile. And of course, you are here because you would like to know, where can I help doing this? How can I help? And yes, we have systems installed all over the world, so maybe this gives you some impression on how these systems look. And of course, to set up such a system is quite a complex task. And doing this task, there are many different steps that have to be done. So first of all, the system has to be sold. So there has to be someone interested in it, right? So that's my part, basically. So I'm the head of sales. So we go to exhibitions when there's still rare exhibitions. Hopefully there will be again. We go to exhibitions here in Europe and all over the world, basically. We also have customers visiting our office, or we meet customers at their offices. And of course, sometimes also the evenings are important during these exhibitions. And of course, recently, these meetings mostly happened virtually. Okay, once a customer is convinced that we have the best solution, the construction of such a system has to begin, because we typically optimize the systems to the needs of the customer. So it's usually quite unique what they get. So you have some sort of meeting where the construction is defined depending on the parameters, and a team reviews the construction in the process. And in the end, you have a virtual model of the system, and you know how it's going to be built. That's when the next step comes. So it has to be developed and produced, so optically. So you have to set up quite a lot of complex optics and mostly mirrors and lenses and all of that. I'm sure most of you have worked with something like that. It all has to be aligned, and of course this is a teamwork, so usually you don't work alone at these systems. So there's always a project manager that reviews the progress and gives you the tasks. And in the end, also the software and electronics have to be optimized to the system. So of course the user wants to have a simple software in the end that controls all the features. So this is also part of the development and production. And once a system is finished, it has to be installed and maybe also serviced once in a while. So this is maybe the most exciting part about the work at such a company, because we have customers all over the world. Well, we always say all over the world, but of course the focus is in North America, Europe, and Asia. And and when you travel for the installations or service visits, you always have the opportunity to stay a few days extra. And as you can see, you can visit some quite interesting locations all over the world as well. And we really like to do things together as a team, even outside of work. So we have at least one team event every year, and regularly we cook together to celebrate big projects or something like that. And we also have lots of sports activities embedded in the company. So we participate at local runs or different team events like paddling and things like that. And the location I already said, we are situated in Jena, which is quite a beautiful town or city actually in Germany. And I guess most of you have been there or have seen it if you participate here. But it is really worth a visit and also a nice place to live. So I'm sure that is a benefit for our open positions as well. Let's talk about our open positions. So we are, as I showed you, we are growing. So of course we are looking for new people to help our team. And currently we are mainly looking for technical staff, which suits well to this conference. And in particular, people who like to travel and like to see the world and service lasers. And of course you will be trained before you start doing that. But this is an interesting part of the job, I would say. And yes, for the more advanced people who have more experience working with fibers or optics in general, laser developer is also like the next step where you could work at in our company. For applications, you can contact the email address I've written below, or you can also contact me on LinkedIn or via this platform. And what we expect from you, well, of course, there are more things that can be important, but this is basically the 3 points that are most important for us. It is necessary that you are a team player in some way. Of course, you have to collaborate with other people, and also you have to talk to customers if you service systems and things like that. So it is very helpful if you like other people. And the willingness to travel, not all the time, of course, but from time to time, or even in service, you won't be traveling 24/7, of course, but it is important that it happens once in a while, or sometimes even more regular. And naturally, but this is sure anyways for you guys, a technical background, so some experience in the fields of physics or engineering, optics, is, yeah, of course, requested. Okay, if you want to take a further look at our company, you can visit our labs in a virtual lab tour on our website. So we have a Google Street View of our lab. So I think this is quite interesting to get an impression of a potential work environment. Yeah, and apart from that, thank you for your attention, and I'm happy to answer questions, or yeah, I'm available for any feedback. Thank you.
Sorry, I have a question.
Yeah, sure.
Do you have any vacancies for the students that want to start the master thesis?
Yes, we do, actually. Sorry, I didn't point that out, but yes, we do. We have bachelor and master students already, I think 2 at the moment, but we're always open for applications, sorry. Yes.
Thank you. And is there any restriction for someone that know a little bit German language? Yes.
No, that for the bachelor and master students, that's fine. Typically, if for a long-term commitment at the company, it is helpful to speak German at least a bit. But it is all right, because all of the technical stuff, they also speak English, and supervisors, they speak English anyways, because those are also all PhDs. So that is no problem.
Okay, thank you. And about the traveling, you said that you have some traveling to some, is it to abroad, to some countries, or the cities in Germany, you mean?
That depends. So we have customers, well, the focus is in Europe. Most of our customers are in Europe, but we have customers in North America and Asia. And of course, if someone is working in our technical departments, then depending on what has to be done to service the system or install a system, different people might have to travel. So it is, of course, helpful if you are willing to travel to all countries. But if due to some visa restrictions or whatever, this is not possible, then I'm sure we can also find a way for that. So, and of course, doing master thesis, you don't have to travel.
Yeah, just I'm thinking about future. Okay, yeah. Thank you.
Yes, I do.
Hello, do you hear me? Hello, thank you. The presentation was really interesting, and I was wondering, are you also like just for master thesis? Also, like, are you looking for like available for potential internships?
Internships are also an option. So depending on the duration, of course, because it is, yeah, there's some effort like to introduce someone new, and we would like to have them to stay for a little while at least. But let's say if you're talking about, yeah, more than a few weeks, maybe 1 month, 2 months at least, then this is surely an option. Yeah.
Okay, great. Thank you.
Okay.
Sorry, Jess, I have one short question. For the master thesis, is there any deadline to apply for your master thesis field, or there is no deadline?
No, for us, this is fine. So typically the way we do it, usually you need a supervisor from academia anyways. So we can only be the industrial partner, and to us, we are not restricted to the academia in any ways in terms of semesters or something like that. So we are flexible there. And the supervisor from academia, we can also recommend someone here in Jena. But of course, they also have to agree to supervise the thesis. So it is easier if you already have someone who supervises the thesis, like on the academia side, and we are the industrial partner. But both things are possible. So
yeah, thank you.
I have a question. You have mentioned that your company is a spin-off of, spin-off from your professor project. So, like, I mean, am I right or?
Yes, we are a spin-off from Fraunhofer Institute and the University in Jena. So that was like 12 years ago already. So we are quite matured by now. Yeah. So.
Okay, fine. And then, like, I mean, do you offer any kind of industrial PhD, like doing I mean, your professor as a second advisor or something like that?
It's the same as for the masters and bachelors. So technically, we cannot supervise a PhD like on a we cannot grade it and things like that. So you need a professor, of course. But if the PhD is like centered around the industry, then we can be the industrial partner for the PhD program. Yes, that's possible.
Okay, and then I mean, you mentioned that I mean, your labs are your major customers, so they are like university labs, and then some labs like this Fraunhofer lab, right? Am I right?
Yes. So big research facilities, universities, Fraunhofer, Max Planck, and also other structures all over the world. Yes.
Okay, fine. I mean, I'm also working in this semiconductor, and I mean, I did my master's in this laser-induced plasma projects, and then currently I'm like working as a patient-served chemitameter, but my contract will be like ending till the next year. So, when would you prefer to apply? I mean, I'm mostly I'll be starting from the month of April 2022, if it is the case.
Sure. But I can only present the positions in general. So of course, just send your application to the email address. I can also write it in the chat again, and then you will hear back from us.
Okay, fine. Yeah, thank you.
Okay, it feels like that was all the questions for now. So yeah, you have the email address, and you also have my name, so you can surely find me and contact me if you have further questions. And yeah, enjoy the rest of the event. And thanks for the organization to the team from Photonics Days. And goodbye.
Thank you. Bye.
Thank you.
Thank you very much.
Bye-bye.